This tutorial will cover how to set up plots, gates, and experimental sample groups. After unmixing has been calculated, a default unmixed worksheet will appear in the experiment. While this new worksheet is selected, click Save As to save an experiment-specific worksheet. Click the Edit button and navigate to the Groups tab. Click the Group button to add a new group folder for your experimental samples. You may name your groups and tubes in this section, or you may also name them in the experiment later. Click Next to optionally add marker labels to your new group. In the Acquisition tab, select the experiment-specific unmixed worksheet from the Worksheet drop-down list. If you have unmixed your experiment, use an unmixed worksheet when viewing your data. On a raw worksheet, you will see the data without the unmixing calculation. Now, adjust your recording limits. We cannot select a stopping gate because the selected worksheet does not have any gates created. Once you add gates to the worksheet, you can return to the Acquisition tab to change your stopping gate. Set the events to record, stopping volume, and stopping time to your preferred values. Keep in mind, whichever limit is reached first will prompt the recording to stop. If you click the Count and Volume stopping criteria, the recording will continue until both the events to record and stopping volume limits have been reached. Click Save and Open. In the group list, click the arrow next to your new group to open the group folder and activate the new sample tube by clicking the green arrow. When you activate a tube, the worksheet attached to the tube will automatically open. Now, let's add the plots. In SpectraFlow, we can create pseudo-color, dot, and histogram plots. To add a plot, click the appropriate icon, then simply click in the worksheet or click and drag. You may want to add a width signal to the forward scatter or side scatter channels if you prefer to identify the singlets based on the width parameter. Click on Signal in the Instrument Control section, then check the boxes for forward scatter and side scatter width. To change the channel on an axis, right-click on the axis label and choose from the available channels. For the singlet plot, we will use forward scatter width versus forward scatter area. But you may use any combination of height, area, or width either on forward scatter or on side scatter. Next, set your fluorescence plots according to your experiment. In this example, we want to identify CD45 positive cells, then analyze the cells that express CD3 and CD8. Before we add any gates, let's add a population hierarchy by clicking the icon next to Statistics. The hierarchy will show the order of our gates, as well as their percentages and counts. Click Start to run your sample, to build the gates around the populations of interest. Once sufficient events are acquired and the populations become well-defined, click the Pause button. Now you can take as much time as needed to edit the plots and draw the gates without wasting sample. Alternatively, you can record your sample right away and add gates while the sample is recording. Gates and plots can be adjusted at any time, so feel free to use the workflow that best suits your preferences. The first plot that was automatically set by SpectraFlow on the unmixed worksheet is a pseudo-color plot. If you would like to change the plot type, right-click on the plot and click Properties. This will open the Properties section on the right side of the screen. There are many useful settings in the Properties section, so you may want to keep it open while you perform your analysis. To change the plot type, click the drop-down menu next to Plot Type and select the appropriate type. For creating gates, there are several options in the worksheet toolbar: polygon, rectangle, ellipse, interval, quadrant, etc. To add a gate, click the icon, then click in the plot of interest to draw the gate. To rename the gate, double-click the gate name in the population hierarchy or change the name in the Gate Properties section. You can also change the color of your gate. To show a population in a plot, select the plot, then click the drop-down in the Plot Gate section of Properties. Click the name of the gate you would like to view in the plot. Alternatively, you can drill down by double-clicking on the gate of interest to create a new plot that shows only the events in the double-clicked population. Repeat this process until all gates are set. To set a stopping gate, navigate back to the Acquisition tab in the Edit section to make that change. The threshold on the triggering parameter is an important concept in flow cytometry. The signal generated on the triggering parameter, typically forward scatter, is continually monitored by the electronics of the instrument. If the signal intensity of the triggering parameter is below a certain threshold, no signals are recorded. When the triggering signal is above the threshold, the signals on all parameters are measured and recorded as an event. On Aurora systems, the triggering parameter is by default set on forward scatter, and the threshold value is 50,000. For certain applications, it may be necessary to modify the threshold value or even use a different triggering parameter. For example, if a sample contains a large amount of debris, it may be advantageous to increase the threshold value, thus preventing the software from recording in the f.cs file too many events corresponding to debris particles. If you have not yet recorded your sample, click Record. Add any additional tubes to your experiment. To add a new tube, click the New Tube icon in the group list. As long as the new tube is within our experimental sample group, it will have the same acquisition settings as our previous sample. Continue to record the remainder of your samples. This concludes gating and acquisition setup. In the next tutorial, we will show you how to export your data from SpectraFlow.